We are from Group 4. In this video, we will explain about the standard error of the mean, the distribution, Pearson index of skewness, Chebyshev's rule, and the last is kurtosis. Hi everyone, my name is Kayla Medista and my last student number is 085. Here, I will explain about standard error. What is standard error? Standard error is a statistical term that measures the accuracy with which a sample represents a population. In statistics, a sample mean deviates from the actual mean of a population. This deviation is the standard error. The term standard error is used to refer to the standard deviation of various sample statistics such as the mean or median. For example, the standard error of the mean refers to the standard deviation of the distribution of sample means taken from a population. The smaller the standard error, the more representative the sample will be of the overall population. The standard error is also inversely proportional to the sample size. The larger the sample size, the smaller the standard error because the statistic will approach the actual value. If you measure a sample from a wider population, the average or mean of the sample will be an approximation of the population mean. But how accurate is this? If you measure multiple samples, their means will not all be the same and will be spread out in a distribution, although not as much as the population. Due to the central limit theorem, the means will be spread in an approximately normal, bell-shaped distribution. What the standard error gives in particular is an indication of the likely accuracy of the sample mean as compared with the population mean. The smaller the standard error, the less the spread, and the more likely it is that any sample mean is close to the population mean. When there are fewer samples, or even one, then the standard error, typically denoted by SE or SEM, can be estimated as the standard deviation of the sample, a set of measures of x divided by the square root of the sample size. Look at this example. This example shows 4 samples of increasing size. Note how the standard error reduces with increasing sample size. Now we move to the discussion. The standard error gives measure of how well a sample represents the population. When the sample is representative, the standard error will be small. The division by the square root of the sample size is a reflection of the speed with which an increasing sample size gives an improved representation of the population, as in the example above. An approximation of confidence intervals can be made using the mean plus or minus standard errors. Thus, in the above example, in example 4, there is a 95% chance that the population mean is within 2 multiplied by 0.70 of the mean, 4.78. Look at this example. Graphs that show sample mean may have the standard error highlighted by an I bar, sometimes called an error bar, going up and down from the mean, thus indicating the spread, for example as below. This graph shows the average height, mean height of men and women. The bars show the mean average height. 1 bar is for men and 1 bar is for women. The small lines on top of the bars are called error bars. They show the standard error. For the simple meaning, the bar means average height, the line means how sure we are about the average. For the longer line mean more variation, and shorter line mean less variation. Alright, I think that's all from my material, and my friends will continue explaining about standard error of the mean. Thank you.
Hello everybody, my name is Davanza Nugraha and my last number is 084. And today I would like to explain to you about standard error of the mean. Standard error of the mean. The standard error of the mean is the standard deviation of the sample mean estimate of a population mean. It is usually calculated by the sample estimate of the population standard deviation or sample standard deviation divided by the square root of the sample size, assuming statistical independence of the values in the sample, where SEM here means standard error of the mean, S means sample standard deviation, and N here means size or number of observation of the sample. So the formula is sample standard error of the mean equal sample standard deviation divided by the square root of N. Now, the following here is the sample standard deviation formula. And the formula is S equals the square root of 1 divided by N minus 1 multiplied by the sum of X sub I minus the mean all squared. Distribution. A distribution in statistics is the way data values are spread out or arranged, showing how often each value occurs. In simple words, a distribution shows the pattern of data. Now, for example, the figure shows how distributions develop as the number of coin tosses increase. With 1 or 2 coins, outcomes are limited and scattered. As more coins are added, outcomes cluster around the center. And when many coins are tossed, the distributions become symmetrical and forms a normal distribution. With most outcomes near the mean, it shows that as the number of the trial increases, random outcomes form a predictable normal distribution. Alright, there are 2 common types of distributions. That is normal distributions and skewed distribution. The first one is normal distributions. A normal distribution is a symmetrical bell-shaped distribution where most data values cluster around the mean and values become less frequent as they move away from the center. And the second one is skewed distribution. A skewed distribution is a type of data distribution that is not symmetrical. This means the data is pulled more to one side, creating a long tail or either the left or the right. And there are 2 types of skewed distribution. There is negative and positive skewed. A negatively skewed distribution, or also called left skewed, is a distribution where the tail extends to the left and most data values concreted on the right, and a very low values pull the distribution to the left. And a positively skewed distribution, or called right skewed, is a distribution where the tail of the data extends to the right. Most data values are concentrated on the left, and a few very high values pull the distribution to the right. Now, the coefficient of skewness is a measure for degree of symmetry in the variable distribution. Negatively skewed distribution, or skewed to the left skewness, is less than 0. Normal distribution symmetrical skewness is equal to 0, while positive skewed distribution, or skewed to the right skewness, is more than 0. Pearson's index of skewness. Pearson's index of skewness can be used to determine whether the data is symmetric or skewed. If the index is between -1 and 1, then the distribution is symmetric. If the index is less than -1, then it is skewed to the left. And if it is more than 1, then it is skewed to the right. And here is the formula for Pearson's index of skewness. Now, the formula for Pearson's index of skewness is Pearson's index of skewness equals P equals 3 multiplied by the mean minus the median, all divided by S.
Hello everyone, my name is Hasana Putri and my last student number is 082. Now I'm going to continue my friend's explanations about Chebyshev's rule and kurtosis. Chebyshev's rule states the minimum proportion of observations that lie within k standard deviation from the mean for any distribution where k is greater than 1. The formula for Chebyshev's rule is 1 minus 1 over k squared where k is greater than 1. This means that at least 1 minus 1 over k squared of the observations will lie within k standard deviation of the mean. For example, at least 3/4 or 75% of the observations lie within 2 standard deviation of the mean. And at least 8/9 or 89% of the observations lie within 3 standard deviations of the mean. And now, I will explain how to verify this rule. First, rank the data from lowest to highest. This is not necessary, but it makes it easier. And second, find the mean and standard deviation of the data. And third, find the lower boundary by multiplying the standard deviation by k and subtracting it from the mean. Fourth, find the upper boundary by multiplying the standard deviation by k and adding it into the mean. Fifth, count the number of values between these two boundaries. And finally, divide the number of values between the boundaries by the total number of values. And now, I will move on to kurtosis. Kurtosis is a measure of the degree of fitness of a frequency distribution. It describes how the data are distributed around the mean compared to a normal distribution. There are 3 types of kurtosis. The first, Platy-Kirchhoff distribution. This distribution has a low degree of fitness and its kurtosis is less than 0. And the second, Measure-Kirchhoff distribution. This distribution is the normal distribution and its kurtosis is equal to 0. And third is Lepta-Kirchhoff distribution. This distribution has a high degree of fitness and its kurtosis is greater than 0. And the formula for kurtosis is delta equals the expected value of x minus mu to the 4th power divided by sigma to the 4th power minus 3. For a normal distribution, the value of the expected value of x minus mu to the 4th power is equal to 3. If delta is greater than 0, the distribution is Lepta-Kirchhoff. And if the delta is less than 0, the distribution is Platy-Kirchhoff. And if the delta is equal to 0, the distribution is Measure-Kirchhoff. In conclusion, statistics help us understand how data are distributed, how they vary, and how accurately a sample represents a population. Distribution describes the pattern of data values. A normal distribution is symmetrical and bell-shaped, while skewed distribution can be positively skewed or negatively skewed depending on the direction of the tail. Skewness measures the degree of symmetry in a distribution, and Pearson's index of skewness can be used to determine whether the data are symmetric or skewed. Kurtosis measures the degree of fitness or flatness of a distribution. A Platy-Kirchhoff distribution has a low degree of fitness. A Measure-Kirchhoff distribution represents the normal distribution, and a Lepta-Kirchhoff distribution has a high degree of fitness, meaning there is more concentration of data at the center. And standard deviation describes how spread out the data are around the mean. It is a key measure of variability and is used in many statistical rules and formulas. Meanwhile, Chebyshev's rule states that for any distribution, at least a certain proportion of data will lie within k standard deviation of the mean. This rule is useful because it applies to all distribution, not only normal ones, and guarantees a minimum amount of data within given limits. Standard error measures how accurately a sample mean represents the population mean, and it is calculated by dividing the sample standard deviation by the square root of the sample size. As the sample size increases, the standard error decreases, meaning the sample mean becomes a better estimate of the population mean. Standard error is also useful for constructing confidence intervals and interpreting error bars in graphs. And overall, these concepts work together to help analyze data, interpret distributions, measure variability, and evaluate how reliable sample results are when making conclusions about a population. I think that's all from us. Thank you for watching.